morning students. So I am maths teacher. Today Wednesday I am going to continue the chapter surface area and volumes. So in this chapter, so 15.1 exercise has been completed already. So today Wednesday, I am going to start a new exercise, that is 15.2. 15.2. See the children. So see the textbooks, page number 136. In that 15.2 exercise, first question like this: a solid is in the shape of a cone. A solid is in the shape of a cone standing on a hemisphere with both the radii, so being equal to 1 centimeter, and the height of the cone is equal to its radius. Height of the cone is equal to radius. Find the volume of the solid in terms of pi. So wherever pi has come from, don't substitute the value to 22/7. So just you can keep the pi value as it is. So according to question, let us see here. So see the first sentence what he has given here. The first sentence is like this: a solid is in the shape of a cone standing on a hemisphere. See the figure like this. We are going to get figure like this. This is the hemisphere. So this is the hemisphere. This is the diameter. So on this the cone is standing. No, the cone is standing there. So with their radii being equal to 1 centimeter, so both our radii are same here. So this radius, so the radii r is same here. So what is the meaning here? The radius of cone is equal to the radius of hemisphere. So let it be, this is this is equal to 1 centimeter. So is equal to 1 centimeter. So therefore radius of, so this is the height. So this is radius equal to 1 centimeter. So r is equal to 1 centimeter. Yes, r is equal to 1 centimeter. And the height of the cone is equal to its radius. One more is given here. So radius of the cone, this is equal to, so you can write here only, height of cone also same. Height of cone also 1 centimeter. So radius also 1 centimeter and height of the cone also 1 centimeter. And here radius of the hemisphere also 1 centimeter. See here, all are equal to 1 centimeter. Hemisphere radius and cone radius and height of the cone also 1 centimeter. So next sentence like this: find the volume of the solid in terms of pi. So volume of solid is equal to question mark in terms of pi. So by looking at the figure here, we have been seeing the two figures here. One is hemisphere, another one is cone here. So here, first we should find out the volume of the hemisphere. We know already last class yesterday. So what is the volume of the hemisphere formula? 2 by 3 pi r cube. And here volume of the cone. Volume of the cone is, that is 1 by 3 pi r square h. So substitute the value and simplify. So let us see here. So how to find out volume of this solid. So volume of solid is equal to, so volume of hemisphere plus volume of cone. So see here, volume of hemisphere. Volume is what here? So how much space is there inside that hemisphere, or capacity of the hemisphere. And similarly, volume of cone is same again. How much capacity it holds water or any quantity that is. Okay, that is the volume here. So volume of hemisphere plus volume of the cone together, if you add it, you are going to get volume of resultant solid here. So substitute the formula, sir. This is volume of hemisphere. What is volume of hemisphere formula? So we know that yesterday 2 by 3. So pi r cube. Volume of hemisphere is 2 by 3 pi r cube plus volume of cone is 1 by 3 pi r square h. 1 by 3 pi r square h. So here we know that already, so 2 by 3 as it is, pi also as it is, because he is asking in terms of phi, answer is asking in terms of phi, so therefore don't substitute your pi value, and r value we know that r value, radius of cone, radius of hemisphere, all are same equal to 1 centimeter, that is equal to 1 cube plus, so 1 by 3 here, 1 by 3 plus pi again as it is, so r value is again, so volume of the radius of the cone is also same, that is equal to the radius of the hemisphere, that is 1 square into height. So which height is height here? This is the volume of the cone, no? So height of the cone is, that is also 1 here. So here substitute the values, you are going to get the final is the answer. So this is the your main problem. So what is the main here? So you should know the volume of the hemisphere formula and volume of the cone formula. So if you add these two, this is call it as 1, call it as 2. If you add these two, you are going to get volume of the solids. I think understood now? So once again, volume of the sphere formula what? 2 by 3 pi r cube, and volume of the cone is, so 1 by 3 pi r square h. 1 by 3 pi r square h. So our radius we know that already, that is 1 centimeter. So in cone also, cone radius also 1 centimeter. This pi value because same constant, because we are asking the result in terms of pi. So next questions. So next question, second question. See the second question here. So Raquel, an engineering student, was asked to make a model shaped like a cylinder. So with two cones. So attached to its two ends by using a thin aluminum sheet. Full stop. The diameter of the model is 3 centimeter and its length is 12 centimeter. Full stop. If each cone has a height of 2 centimeter, find the volume of air contained in the model so that Raquel made. So in bracket given, assume the outer and inner dimensions of the model to be nearly the same. So here engineer students model is made a model, sir. The model is like this. So Raquel, he was an engineering student. So he made to make a model shaped like a cylinder with two cones attached to its two ends. See here, first he took a cylinder here. For this cylinder at the end points he attached the what attached here? So two cones are attached to its ends, two cones. So cones means like this. Now two cones is attached here. So two cones is attached here. Okay, two cones is attached at the so ending of the cylinder by using the aluminum sheet. The diameter of the model is 3 centimeter. So we know that this is the, if you take this is the axis, sir. So this is radius here. He has given the diameter of the model. So diameter of the model you can write here only. So this is the diameter, that is d is equal to 3 centimeter. Diameter of the model is d is equal to 3 centimeter. So d is equal to, so diameter, so d is equal to of model, d is equal to 3 centimeter. So model here, because all these cones and these cones attached to the ending of the cylinder, so that therefore, so cone diameter also 3 centimeter, and because these two are same here, attached to one end to the another end, so all the diameters are equal to the 3 centimeter only here. So diameter of model is 3 centimeter. Therefore, so radius of cylindrical cylinder, cone is equal to, that is r is equal to d by 2. So 3 by 2 is nothing but 1.5. So we know that this radius r is equal to 1.5. So this cylindrical radius also r is equal to 1.5. Here cone also r is equal to 1.5. All the radius are same because diameters are same. Diameter of model is 3 centimeter. Therefore radius also same here, all is equal to d by 2, that is 3 by 2, nothing but 1.5 centimeter. So that is centimeter. Okay, sir. Next
coming to its length means what? So model length here. So model length means we can take from here to here, model length. So model length or height is equal to how much centimeter here? So diameter of the model is 3 centimeter and its length is 12 centimeter. 12 centimeter. So 12 centimeter. If each cone has a height of 2 centimeter, suppose you take the height of cone is 2 centimeter. That is you can take H1, that is 2 centimeter. So this is also here. I can take here. Here also H1, that is 2 centimeter. Both are same here. H1 and H1 height are same here. So 2 centimeter. Find the volume of air contained in the model. How much air it should be contained in this total model? At the model that Raquel made. So you should find out how much air is nothing but what? Finally you should find out the volume of the model. So here how many solids are, can you see here? Can you see? One is here cylindrical part is there middle. So at the top is here cone is there, volume of the cone, and down bottom also volume of the cone. So here, see here. So volume of, so model, volume of model is equal to, volume of model is equal to, volume of model is equal to, so before this one you do one thing here. So first you find out height of the cylinder here. Height of cylinder. What is the height of the cylinder here? See a total model height or length 12 centimeter from here to here. So height of the cone is here 2 centimeter. Here cone is 2 centimeter. Here 2 plus 2, 4. So in that total 12 centimeter, so minus 4 centimeter, if you subtract it, you are going to get height of the cylinder. So height of the cylinder is equal to 12 minus 2 plus 2. Why 2 plus 2? Because two cones are there. Each cone of height is 2 centimeter. 2 plus 2, 4. That is equal to, so 12 minus 4 is equal to 8 centimeter. This is the height of the cylinder, 8 centimeter. This is 2. This is 2. Cone is 2. Cylinder height is 8 centimeter. That is H1. So this is, we can take H2. H2. So now let us see here. So how to find out volume of the total model here. This volume of the model is equal to, so volume of the cylinder plus 2 times of volume of each cone. Why it is 2 multiply? Because 2 cones are attached to end of the cylinder. So therefore you write 2 into volume of the each cone. So I am writing, look at here. So now first volume of cylinder plus, so 2 into, because this cone and this cone, 2 cones are there, no? 2 into, so volume of each cone, volume of each cone. 2 into volume of each cone. 2 into volume of each cones. So here, so is equal to volume of cylinder formula what? So yesterday written on the board, that is all the formula, surface area, lateral surface area, volume, so all written on the board here. Here volume of cylinder formula is, so area of the base into height, or nothing but, so pi r square h. H means what here? Which height here? Cylinder height, no? H2 we can write. Because cylinder height, I want cylinder height, so cylinder height only are represented by here H2, so H2 you write. So pi r square H2. So area of the base into height. Plus is there, plus 2 into, what is volume of each cone? So volume of each cone formula is, that is so 1 by 3 pi r square h. H means which h is here? Height of the cone here. That is nothing but h1. That is nothing but h1. Square bracket you use it. So next, this is the, substitute the value here, you are going to get volume of the model here. So now here pi value 22 by 7. Pi value is 22 by 7. So however you can simplify here, R value, which R this is? Radius is all same, that is 1.5. So 1.5 radius 1.5 whole square into H2 is, so this is the which height? Cylinder height. H2 is 8 centimeter. So plus, so next here 2 as it is into 1 by 3 into 22 by 7. Again radius of the cone, radius also same here, that is 1.5. So 1.5 whole square into H1 is height of the cone. So that is 2. So like this, if you simplify, we are going to get volume of the model here. So understood now, children? So this is a second problem here. So next we are going to see that is a gulab jamun problem is there. Next one, that gulab jamun problem also same here. See here, I'll give the hint. You can do it at home here. You can try to do. This is the third problem, the gulab jam. So you can see the figure. So many gulab jams are there in the bottle. I am taking only one gulab jam here. So gulab jam like this shape. That is so this shape is there. So see here, it is just like a container like this like shape, container shape like this. This is, so if you divide it here you also divide it. So how many parts it becomes here? How many solids here? So middle is the cylinder. So cylinder end point here, one is hemisphere, so another hemisphere here. So we know that already hemisphere formula, we have volume of hemisphere and this volume of hemisphere and volume of the cylinder. If you add it, you are going to get the answer that you can do yourself. So next, so fourth problem is there, fourth problem. So that fourth problem, okay, fourth question, so question number 4 here. Question number 4. So you can see the question number 4. So a pen stand made of wood is in the shape of a cuboid. So with 4 conical depressions to hold the pens. The dimension of the cuboids are 15 centimeter by 10 centimeter by 3.5 centimeter. So full stop. The radius of each of the depressions is 0.5 centimeter and depth is 1.4 centimeter. Full stop. Find the volume of wood in the entire stand. So I think you might have seen the pen stand here, keeping the pen now. So in the figure you can see that figure. So pen stand is there here. So this is so roughly I am drawing the pen stand here. This pen stand 1, 2, 3, 4. Pen stands are there. So here first see the question here. A pen stands made of wood. The pen stand, this is the cuboidal shape is there, no? The stand is totally made up of a wood. Wood in the madidare. So it is in the shape of a cuboid shape, that is important here, cuboid. It is in the shape of length, breadth, height is there, okay, cuboid shape. With 4 conical depressions. So here 4 cone shape is there, cone shape 4 are there here. Cone shape how many are there? 4 conical depression is there, 4 conical depressions. Conical depressions. The dimension of the cuboids are, okay, cuboid dimension is given here. For example, this is the height, breadth, so here, this is here. So length is, so dimensions are, dimension is nothing but what? Length, breadth and height. That is called dimension here. So 15 centimeter. So bigger number is always take the length and by 18 centimeter, that is 10 centimeter. So breadth is 10 centimeter and height is, height how much? So that is 3.5 centimeter. 3.5 centimeter. So this is the dimension of the cuboid. The radius of each of the depression is, see here, I am taking zooming here for this one here. So I think a pen depression like this will be there, no? Nothing but cone shape this is. Cone shape this is. The radius is given. That is R is equal to, radius R is equal to 0.5 centimeter. So decimal you can convert here 5 by 10. 5 by 10 is nothing but 1 by 2 centimeter. 1 by 2 centimeters. Okay, sir, this is for convert it. And depth is 1.4 centimeter. Depth means what? Height. Depth is nothing but what? Height. That is, height is equal to 1.4. 1.4 centimeter. 1.4 centimeter. Find the volume of the wood in the entire stand. So, how much wood is used here? So, that is nothing but what? Volume of the wood. You have to calculate it. How much volume is required to make this cuboid. So, here he has given the radius, he has given, and height also given. So, you should find out first volume of the cuboid. You should find out volume of the cuboid formula. We know that length into breadth into height, that you are going to get all flat surface on the top also top surface. If plane assume that, so you are going to get entire volume of the wood. Then afterwards, in that you subtract. What subtract? 4 conical depressions are there. That 4 conical depressions, how volume of that 4 conical depression you have to subtract in the volume of the cuboid. How? If calculate first volume of 1 conical depression into 4, you can multiply. You are going to get so 4. How much volume of the volume of each conical totally entire 4 conical depression volume you are going to get. So now see here, first calculating here. So first each volume of conical depression. Depression means down. Conical shape in downward is removed out, is equal to is cone because of cone shape. Now that is volume of cone formula. We know that is 1 by 3 into pi r square h. 1 by 3 into pi r square h. So 1 by 3 into pi. So r means radius here. That is pi r square h. So this is capital H. You can take this small h. I took here height of the cuboid. Here you can take capital H here. So that is equal to 1 by 3 into 22 by 7 into r value what here? Radius is so 5 by 10 or nothing but here 1 by 2. 1 by 2 square into height is capital height. So this is height of the cone, that is equal to 1.4. This 1.4 can be written as 1 by 14 by 10. So that is 2 7s are 2 5s are, that is 7 by 5. 7 by into 7 by 5. 7 by 5. So this is your one conical difference, volume of each conical difference. So for this one, so you multiply into 4. So into 4, why it is multiply? Because here 4 conical depressions are there. So into 4, you are going to get. So next, don't want here. So here total volume of 4 conical depressions. Conical depression is equal to, so 4 into this one, 1 by 3 into 22 by 7 into 1 by, so 1 1 ja 1 2 2 ja 4 here, so into here 1.4. So 1.4 is nothing but what? So radius 7 by 4 written here. 1.4 is nothing but what here? 7 by 5. 7 by 5. So this gives the total volume of 4 conical depression. 4 1 2 3 4. So now here, so volume of is asking what's here? Find the number of volume of the wood in the entire strand is equal to, so volume of wood is equal to volume of wood in the entire stand is equal to, so volume of cuboid, total volume of the cuboid minus volume of the 4 conical depression. See here, volume of the wood in the entire stand is equal to volume of the cuboid minus volume of 4 conical depressions. Volume of the cuboid formula we know that is length into breadth into height minus of this 4 conical depressions volume I already calculated here. Here I already calculated, that is 4 into 1 by 3. 4 into 1 by 3 into 22 by 7 into here 7 7 you can cancel, 7 1 ja 7 1 ja cancel here. So again, so 22 divided by 4 3 ja 12, 12 5 ja 60, 60, 12 5 is 60, sir. So this is so your volume of 4 conical depressions. Next, so here length means length of the cuboid we know that is 15 centimeter. Here breadth is 10 centimeter. Height is how much here? Height is 3.5 centimeter. Nothing but 35 by 10 centimeter. So minus. So you can do it here. So you are going to get you are going to get what here? So total volume of the wood. Volume of the wood in the entire stand here. Next, afterwards again he asking here. So find the volume of the wood in the entire stand. Okay, sir. This is the volume of the, after simplification we are going to get answer. That is the volume of the wood in the entire stands. So this is your problem. So next problem he has given like this. That is the fifth problem. What is fifth problem he has given here? A vessel is in the form of a inverted cone. A vessel is in the form of inverted cone. Its height is 8 centimeter and radius of its top, so which is open, is 5 centimeter. Is filled with water up to the brim. So when the lead shots, so each of which is a sphere of radius 0.5 centimeter are dropped into the vessel. So 1/4 of the water flows out. The volume, find the volume of the lead shots dropped in the vessel. This is water dropped here. So this is completely different from the other problems here. So these problems we can try at home. If not get it, so in offline class details I'll say you this is. So next here, sixth problem is there. See here, look at the sixth problem. A solid iron pole consisting of a solid cylinder of height is 220 centimeter and base diameter to 24 centimeter. So solid iron cylinder. So this is a solid iron cylinder, you assume that. So this is a solid iron cylinder consisting of what? So height is 220 centimeter. So this is a height is 220. This is height, you can take capital H is equal to 220 centimeter. And base diameter. So base diameter means down base diameter, that is D is equal to how much? This is 24 centimeter. 24 centimeter. So which is surmounted by another cylinder. Each cylinder may non cylinder surmounted by another cylinder. Half height is same. See here. Another cylinder I am keeping here. Okay, another cylinder here. So its cylinder height is given again. So this height, cylinder height is, that is called as small h, you can take, that is equal to 60 centimeter. 60 centimeter. And radius is 8 centimeter. So its radius, small r is equal to 8, and this radius you can take capital R is equal to not given here. This is not given. Question mark here. Question mark. So again, find the mass of the pole given that 1 cubic centimeter of iron has approximately 8 grams mass. So 1 cubic centimeter of iron, it weighs 8 grams mass weights here. So means what here? So find the mass of the pole means you should calculate totally volume of this pole, volume of the iron solid iron pole. This volume you should find out here. So volume of the here bigger cylinder plus volume of this smaller cylinder. Then you are going to get total volume of the solid iron pole here. So how to calculate here? See here. Here, so volume of solid iron pole is equal to, so this height we know that is 220 centimeter, but diameter given, radius not given for this the bigger cylinder. So you can calculate radius here, that is equal to capital R, radius is equal to, so diameter by 2, that is equal to, so 24 divided by 2, you are going to get 12 centimeter. 2 1 ja 2, 2 12 ja 20, 2 12 ja 24. So radius I, this is 12 centimeter. This is I found that radius. So this volume of solid iron pole is equal to, so volume of larger cylinder plus volume of smaller cylinder, that is equal to volume of larger cylinder. Formula what? So volume of larger cylinder or any small cylinder, but formula is same. Volume means how much space is there inside that cylinder, that is equal to, so pi r, capital R. No, this is I took here bigger cylinder, radius is capital R, pi r square, h is I took here capital H, pi r square h, but r is capital because smaller radius also is there, that is small r. Bigger cylinder for radius I took here capital R, pi r square h, plus, so volume of smaller cylinder, what is smaller volume of smaller cylinder, that is also pi, but r means what here, smaller radius, that is r square, h is small h here. So if you add volume of the larger cylinder plus volume of the smaller cylinder, so you are going to get 1 and 2, you are going to get totally volume of the solid iron pole here. Substitute the formula, so pi into capital R means here 12 square into height is, what is capital this big larger circle, larger cylinder height is 220 centimeter, so plus is there plus, so next pi is again as it is, so radius R is smaller cylinder radius, so 8 centimeter into h, smaller cylinder height, that is 60. Okay, this pi you can take common here, 12 12 is 144 into again 220 plus as it is, so this pi already I took here common, 8 8 is 64 into 60. So you are going to get what, sir? Finally your answer here. So into pi value, that is 3.142, you can multiply, you are going to get some volume here. So after that volume, after got it the volume, then finally 1 cubic centimeter, how much it is mass, sir? Here he has given 1 cubic centimeter is nothing but 8 grams, that is gm. So how much your volume to getting your answer for this much of volume, how much your question mark you do it, and cross multiplication if do it, so you are going to get answer. So suppose this is the finally you are going to get in gram, in terms of gram. If you want in kg, so you should do it, you want to grams means, so grams divided by kg means 1000, if you divide it, you are going to get kg in terms of kg. ಕೆಜಿನಾಗ ಬೇಕಂತಂದರೆ ಗ್ರಾಮ್ಸ್ ಬಂದಿರುತ್ತೆ ಆನ್ಸರು, ಅದನ್ನು ಡಿವೈಡೆಡ್ ಬೈ 1000 ಮಾಡಿರಿ, ಬಿಕಾಸ್ 1 kg ಈಸ್ ಈಕ್ವಲ್ ಟು 1000 grams, ಡಿವೈಡೆಡ್ ಬೈ 1000 ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಏನು ಬರುತ್ತೆ, ಸೊ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಕೆಜಿನಲ್ಲಿ ಬರುತ್ತೆ ಆನ್ಸರ್ಸ್. ಸೊ ಗ್ರಾಮ್ಸಲ್ಲೇ ಮಾಡಿದ್ರು ಓಕೆ, ಕೆಜಿಯಲ್ಲಿ ಮಾಡಿದ್ರು ಓಕೆ. ಸೊ ದಿಸ್ ಈಸ್ ಯುವರ್ 6th ಪ್ರಾಬ್ಲಮ್ಸ್. ಐ ಥಿಂಕ್ ಅಂಡರ್ಸ್ಟುಡ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಹಿಯರ್ one more problem is given here, a solid 7th problem. Next problem, a solid consisting of a right circular cone of height 120 centimeter and radius 60 centimeter standing on a hemisphere of radius 60 centimeter is placed upright in a right circular cylinder, so full of water, so such that it touches the bottom. Full stop. Find the volume of water so left in the cylinder, comma, if the radius of the cylinder is 60 centimeter and its height is 180 centimeter. So this is I'll draw the figure here, then you come to little idea about that one. So 7th problem, see the 7th question. A solid consisting of a right circular cone of height is 120 centimeter and radius 60 centimeter standing on hemisphere. Cone is standing on hemisphere. Listen here. Half radius is 60 centimeter is placed upright in a right circular cylinder. So this cone and hemisphere is placed in a upright circular right circular cylinder. First you should draw the seventh problem. This is cylinder here. So this is assume that this is a cylinder here. In that cylinder, upright cylinder, a cone standing on the hemisphere here. So this is hemisphere. You assume that this is hemisphere. A cone is standing on this one now. Understood? So first beginning bigger is a cylinder, bigger cylinder. In that hemisphere also is there. Again on that hemisphere, cone is standing on that one. Okay, next one. It is a full of water. So it is this cylinder, circular cylinder full of water. So it is filled with water. So water, so that is water indicates that is water. So water, this is full of water here. Full of water. This touches the bottom. Find the volume of the water left in the cylinder. So if the radius of the cylinder is 60 centimeter, radius of the cylinder. Suppose this is a axis, the radius is here. This is R. Radius of cylinder is what given here? 60 centimeter. R is equal to 60 centimeter. Okay. And height of cylinder is what? So height of cylinder is so height of cylinder is, that is, we can take H is equal to 180 centimeter. 180 centimeter. Next, what given sir here? Right circular cone. Right circular cone he has given. Cone height he has given. See here, shall I take here? From here to here, cone ends now here. So this is a cone height. That height you can take H1 here. This side you can take here. That is H1, because this is H is a cylinder height. This H1 is nothing but what? Cone height. How much this is? 120 centimeter. And radius, how much radius I am taking here? Only radius, that is R is equal to 60 centimeter. R is equal to 60 centimeter. R is equal to 60 centimeter. So this is given here. Hemisphere radius also says 60 centimeter, because the cone is standing on the hemisphere. So therefore both the radius are same here. Cone radius and hemisphere radius are both same here. So we can write here first cylinder part. So I am writing the cylinder part detail here. Cylinder part what given here? Height. So height is equal to, so that is H, small h is equal to, so 180 centimeter. And radius, so these are all about cylinder parts. What I am writing here? Cylinder part, that is small r is equal to 60 centimeter. And okay, this is about cylinder part. Next, cone part. What is cone part here? What are the details given here? Cone part, given data. Height of the cone, that is represented by H1, no? Yes, here height of the cone is H1, that is equal to 120 centimeter. Next, radius is same. So radius, that is R is same for every solid here, that is equal to 60 centimeter. This is about cone part. Next, hemisphere. Hemisphere part. So hemisphere part, what is given detail here? Hemisphere part. So one is radius given, that is nothing but here all radius are equal. Then what is its depth here? Depth also 60 centimeter. So here very important here. So when is the here hemisphere? So radius is equal to the height here. So R is equal to the H. This is very important here. So radius ಎಷ್ಟಿರುತ್ತೋ depth also ಅಷ್ಟೇ ಇರುತ್ತೆ ಇದು. So radius to height same irutte. So here radius he has given 60 centimeter and depth also same, that is 60 centimeter. So here radius, that is R is 60 centimeter. 60 centimeter. And height of hemisphere also 60 centimeter. 60 centimeter. If you take total height is 180 centimeter, if you remove the 12 centimeter cone height, you are going to get hemisphere height, that is. So this is a part of all the part given data I written here. So now he is asking what here? How much water is left? How much water left? How do you find out here? See here, first you should find out so volume of the cylinder. Volume of cylinder. Next, volume of the cone plus volume of the hemisphere. Volume of the cone plus volume of the hemisphere. So in the total volume of the cylinder minus what you should minus here? Subtract here. So volume of the both core and hemisphere you should subtract here. So remaining only the portion, remaining only the volume of the water will remain in here. So now see here how to calculate here. So actually here, so volume of water left, volume of water left in the cylinder, left in the cylinder is equal to so volume of cylinder minus what you should subtract here? You should add this volume of the cone plus volume of the hemisphere, add and subtract in the cylinder here. So volume of cone plus volume of hemisphere. So now see here is equal to volume of cylinder. What is volume of cylinder formula? So already so many times I written volume of cylinder formula, that is pi r square h. Pi r square h. H means what here? Height of the cylinder. Yes, here this is height of the cylinder. Minus here volume of the cone is, what is volume of the cone formula? Cone formula, that is 1 by 3 pi r square h. Which h here? So here h means here cone h. Cone h means I took here h1, no? So h1 right here. h1 is the cone height. So this small this h is the cylinder height here. Minus plus. So volume of hemisphere is, volume of hemisphere formula half lemon, that is nothing but 2 by 3 pi r cube here. So your volume of cone plus volume of hemisphere, you add it and you subtracted in the volume of the cylinder. Cylinder ಅಲ್ಲಿ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು. ಆವಾಗ ಏನಾಗುತ್ತೆ ನಿಮಗೆ? ಸೊ ವಾಟ್ ಎಷ್ಟು ಜಾಗ ಉಳಿದಿದೆ ಅದರಲ್ಲಿ ವಾಟರ್ ಎಷ್ಟಿದೆ ಅಂತ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ look here, that is pi values 22 by 7. So radius is same, that is nothing but 60 centimeter, 60 square. Height is 180 centimeter, cylinder height, minus 1 by 3. Again pi value is, so you can take common here. If you want, you can take common here pi r square you can take common here. So again 1 by 3 here, h1 remains, plus here what is remaining here? So 2 by 3, 1 are remaining here, 1 are remaining here. So now is equal to 22 by 7 into 60 square, 60 into 60 into 180 minus, again pi r value is 60 square. So 1 by 3 into h1 is, which h1 here? H1 is nothing but here height of the cone. How much is that? So into 120 plus 2 by 3, our radius is 60 centimeter. Nothing but into 60 centimeter. Here pi value also you can substitute here, 22 by 7. So after simplifying, so you are going to get volume. So how much volume is there, no? So that much of volume is there, nothing but what? Water will be left here. So this is your seventh problem here. Next, so eighth problem is there. So that is also a spherical glass vessel, has a cylindrical neck, 8 centimeter long and 2 centimeter diameter, and diameter of the spherical part is 8.5 centimeter. Full stop. By measuring the amount of water, so it holds, a child finds its volume to be 345 cubic centimeter. Full stop. So check whether she is correct, taking the above as the inside measurements, that is pi is equal to 3.14. So you do it here. So if you not get it, I'll do it when the revision I'm doing. No, I'm doing, sir.